Hello, everyone. Welcome to our first in person event of the year. And we're also attempting to do something hybrid. So, for the people who are at home, you might not be able to get all the drinks and the swag and everything we have here, but you do get access to great content. So make sure to say where you're listening to us from in the chat. I see not many people joined yet, so I'm going to allow some time for people to arrive. And we don't have like all the lighting and everything ready here, but we're going to try our best to bring the in-person experience to you. So we have our very first talk, which I actually had prepared for you beforehand. So I'm going to share it now with you and feel free to interact with us on the chat. So let me get the file here.
My name is Amanda Cavallaro. I work as a developer advocate at Vonage, and today we're going to build an appointment scheduler using Firebase, Node, Express, and the Vonage APIs. I'm always looking to connect and to learn more what the community has been up to, especially using our APIs, and also to let us know how we can support you. Give us feedback on the documentation, how our resources are helping you out. Firebase helps you build and run apps. It's backed by Google, and there are many people using it nowadays. There are startups to global enterprises. It allows you to accelerate app development with fully managed backend infrastructure, release with confidence and monitor performance and stability, to boost user engagement with analytics, A/B testing, and messaging campaigns. It's time for us to set up the project we're going to use for this workshop. From the Firebase console, click to add a new project. Give it a name and make sure that the ID you're creating is something of your liking, because once you click Save and Create Project, that's going to be the ID and it cannot be changed. Select the option to enable or not analytics and click to create the project and wait for your resources to be created. Set the billing type by clicking on the gear icon, followed by Usage and Billing. Then on the Details and Settings tab, we're going to modify the plan to use Blaze. This pay-as-you-go plan is required when you're using a third-party API. We're now going to create a Firebase real-time database instance. This type of database makes it possible for us to store and sync data among our users, as its name says, in real time. People can then access the data via web or mobile, and it helps the user collaboration. Whenever we update data in the real-time database, this data is stored in the cloud and it notifies all the interested devices. Let's click to create a new database and select the location where the data will be stored. Then we're going to choose in which mode we're going to use it, either locked or in test mode. When it's set to locked mode, there are restriction access to your data, and when you use it in test mode, you allow anyone to access it. We're going to add our own security rules going ahead, so choose either right now, and now you have your real-time database instance created. From your terminal, install the Firebase Tools with npm if you don't already have them by typing npm install -g firebase-tools. Next, type Firebase login. This will open a window in your browser which will either authenticate you automatically if you're already logged in or ask you for your credentials. Once that's complete, you now have the Firebase CLI installed. Whenever we're going to book an appointment, we expect some slots to be already taken. So let's create a myappointments.json file, which is going to contain some information previously. We are adding 3 appointments that have different dates and user IDs. I've created my myappointments.json file using Nano, but you can use any text editor that you wish. Save that file to your machine and import it from the real-time database UI by clicking Import JSON. Then you click Browse, look for the file in your computer, and import it to the real-time database. Now you can see all your 3 slots appear there. Let's add the database rules. The Firebase real-time database rules determine who can access your database, how your indexes are built, and how your data is structured. From the Firebase console on the real-time database view, you can see Rules. Click on that tab. You'll be taken to a screen that will allow you to edit your rules. We are going to add on the dots read when the data is allowed to be read by users and when it's allowed to be written, and we're going to set the My Appointments collection to be indexed by the date field. After that, we're going to click on Publish. In order to set up our project, we're going to create the folder. After that, we're going to change directory inside of it. We're then going to initialize npm by typing npm init. This command prompts you to add information about the project. So you can add the package name, the version, a description of what this project does, the entry point file, the test command, the git repository, keywords. We're just pressing enter here, and then you can add your author name, the license, and if everything looks okay, you can press return and open this in your favorite code editor. This file is going to use a number of dependencies. One of them is the Vonage Server SDK, .env, UUID, Express, Firebase admin, and Firebase functions. Since we already created the project in the Firebase dashboard, when you are on your terminal, you can type Firebase init to initialize Firebase, and we're going to select to use an existing project, which will prompt you to choose the desired project. You can see my example with my project ID. I have Vonage Appointment Scheduler-1. I also chose to use the real-time database feature. We're also going to create a public folder to host our static files. We're then going to tell Express to read the static files from this public folder. Create the public index.html file that contains the content for the view to select a new appointment or to cancel them by adding a code. So let's start writing it. Did you know that the HTML input element has many types for date and time selection? For instance, we have date, date time local, time. For this workshop, we were going to use the input type date time local. This approach is perhaps not as robust as using a datetime library, as there can be some inconsistencies, but it works for the purpose of this tutorial. So the user will be able to book slots every 5 minutes. So like it's times ending in 0 or 5. So for instance, 8 o'clock works, but 8:01 doesn't work. We're also going to add inputs for the user to add their phone number, a span class for us to check the validity for the CSS when a date and the phone number are inserted. We're also going to add a book slot button and a form action to cancel the appointment. And this is how our view should be looking now. Let's add some CSS. Create the styles.css file inside of this folder, and for this demonstration web app, we'll add some styling to center the contents on the page. We're also going to display a red cross in case the input is invalid and a tick in case it's valid. Add the styles.css inside the folder called styles. This is how your web page should be looking now. Once you click a time, which is specific, you can see it works. You add the phone number, it works too. It says it's valid. But if I put a non-exact time, you can see there is a problem. And if I don't add the phone number, there is a problem too. Create the .env file and populate it with the below information. The Firebase database URL can be found on the Firebase console. The Vonage API key and the Vonage API secret can be found on the Vonage dashboard. The Vonage phone number contains the number, name, or brand that will appear as the sender of the message. And finally, the Vonage 2 number is the number that will receive the SMS messages. For today's workshop, I'm giving away a free coupon of €10. So make sure that you add your service address. Once that's all added in, you can paste in the voucher code that we're giving away, which is 22ELGDNA. Once that's applied, you can see the balance has changed on the top left of the dashboard. With this new credit that you have, you can buy a number so that we can test the sending the messages that we're doing for this workshop. Make sure you add all of these variables to your environment variables file, and let's crack on. We will create the server.js to tell Express how to handle the requests posted by the UI. From the root of your project, create a script folder, and inside of it, create the server.js. Open your package.json file, and inside of scripts, we're going to add a command that when we run npm run start, it's going to run the script server.js file we've just created. Our web app will use Express, and it will read the static files we have previously created from the public folder. We're also going to add dependencies and import files that we're going to use. It's time for us to create a Firebase service account. It can be used to authenticate various Firebase features. For our project, we're going to use the Firebase admin SDK to access our database URL. So from the Firebase console, click on the gear and select the Service Account tab. Copy and paste the admin SDK configuration to your project. I like to change var to const to keep it very consistent in here. Let's also change the path to the service account key to a file which is going to be added to the root of our project. Go back to the service account on the UI of the Firebase console and click to generate a new key. Once that file is downloaded, add it to the root of your project. Rename it to the name that we gave, serviceAccountKey.json, and now the information is going to be read from there. We use initialize app to create and initialize a Firebase app instance that will use the /myAppointments Firebase database instance that we have previously created and populated from the Firebase console. We create the instance of the Vonage client class, initializing it with the Vonage API key and secret that you have previously added to your .m file. The HTML input type datetime local is formatted as YYYY-mm-DD-THH:\mm. So we will write a function to separate the date from the hour by splitting it on the character T. For instance, in the example 2018-06-12T19:30, we would have 2018-06-12 for the date and 19:30 for the hour. It's time to create the appointment endpoint to handle the post requests for creating an appointment. This endpoint will check if the slot is available. It will add the slot to the Firebase database, and finally it will send an SMS confirmation back to the user's phone using the Vonage Messages API. You may have noticed that much of the functionality within the request handler has not yet been implemented, so let's now expand on the stubs for the required functionalities. Let's create a function to validate if a slot is available by checking if the slot already exists in the database. We are querying ref.orderByChild.date. Queries are allowed to order one key at a time. We have previously defined our index via the .indexOn the Firebase rules for better performance, and we make sure to use dot once value to listen for exactly one event of the value, and then it stops listening. The next function we're going to create adds both a slot and the code to the Firebase database. This code is required in order to cancel the appointments. Finally, once the slot is reserved, an SMS confirmation is sent back to the user with the message, meeting booked at time on date. Please save this code in case you'd like to cancel your appointment. We then use the Vonage API method to send this message via SMS to a real phone. This Vonage Messages API integrates with SMS, MMS, and popular social chat apps. To finalize the business logic, we have this code which is responsible to call the previously created helper functions. If the slot is available, the user will have their slot added to the database and have the SMS back to them. Otherwise, they will be requested to choose a different time of slot. Let's create the cancel appointment endpoint that handles the post requests for canceling an appointment from the database by using a code provided by the user that they have received upon scheduling their appointment. The app will be listening on the port you have specified before. If this is run locally, you can access it by typing localhost port from your browser. In this URL, you can interact with the UI of this demo application and check the slots being added or removed on the Firebase console web page. To test everything we've done today, make sure that all the dependencies are installed and then to start it, run npm run start. Now from the web app, you can notice that if you select the time, the phone number, click to add the slot, you can see it's being changed, it's being updated from the real-time database. In order to cancel a slot, you copy the code from the real-time database console UI, paste it to the UI of your web app, and once you click the button, it's going to be removed from the real-time database. You can see the updates from there. The code of what we've discussed today is available on GitHub, and there's also a written version of this workshop as well. So there are various ways for you to learn, and just let your creativity flow, create other types of appointment booker. Feel free to follow us on social media, apply the code we've given to you today, and thank you very much. I hope to see you soon.
Hello, everyone. I know we don't have the best lighting going on here, and it's a bit weird because I'm looking at a camera, and there's also people standing here. So I kind of just look in the middle. So the venue that's hosting us today is Ibis, and by the way, they have live music here in the evening every Thursday. So you're very welcome to attend. And it's all weird because I don't know if it's the first time that you're attending our workshops or like if you've been attending the past years or if it's the first time. But before it was very different because we were doing this in offices and different places. But these days you just don't know if the office is going to close tomorrow. So we found ourselves a new home here to host our events, and we're very happy with all the brownies and everything we've been eating. So the community that's hosting you today is GDG Cloud London. I have some of my co-organizers here, but they are, if they want to come in the camera, just you heard them woohooing. Yep, they're coming, and watch out for the cables. So we've been around for around 6 years. We all come from different countries. That's very interesting about doing events in the UK because I'm from Brazil.
And all the rest of the team is from Italy. So it's
Yeah.
not many other countries. We have considered also rebranding to GDG Nuvola Londra.
Yeah, so that's in discussion. I don't think it's going to go ahead though. So these events are for the community, but we have many people who partner with us. So for instance, today we have our host, Ibis, as I said. We also have Vonage here, who gave us a bunch of swag and speakers. There's 2 speakers from Vonage. Anything else you'd like to add to say to the people who are watching online and in person?
Yes. We hope that slowly we will be able to re-welcome all of you and start regrowing our in-person community that made us what we are today. Because let's remember that there are 7,000 of us that we've met across the years. We've had like hundreds and hundreds of events. We have helped a lot of people to get a new job, learn new skills, or to just share the knowledge that they accrued through us and with us. So if you want to share something, please reach us, get in touch, and you can be our next speaker.
That's it.
Absolutely same. I can't wait to rebuild the amazing work that we have done pre-COVID. So hopefully we were able to deliver workshop and courses. Do you remember all the courses
How can I forget?
that you've done? So yeah, I'm really excited for the future.
Very good. So shall we invite our first speaker of the evening?
Absolutely. Who is the first speaker?
Who is the first speaker?
Oh,
It's a dear
Okay,
friend
cheers.
that I made through the community, and he brings a very interesting topic today. Oh, it's very dark in there. Sorry for the people online. As I said, we don't have very good light here. But he brought a very interesting lightning talk, and I'll give the stage to him, and I'll try not to trip.
Congratulations, good. When camera?
Don't trip.
When camera, everybody sees me. Hello, virtual people, and hello, people in person. So I'm going to talk about a blog series I made. It's this 100 languages speedrun. I decided that basically there's like thousands of programming languages, but nobody knows most of them. So I decided to just do one language a day for 100 days. I'm so far 74 languages in. This is the list alphabetically. You can maybe recognize some of them, probably not that many. So like I just showed, I guess, a random sample of some of the languages and what the hell I'm doing with this. So oh, by the way, there's also like, if you want a smaller version of this, there's a book called 7 Languages, 7 Weeks, which is like a good introductory version, because I don't really recommend people to do 100 in 100 days. That is maybe a bit much. But if you want like a beginner version of this, there's even a book for that. That's a pretty good book with just 7 very different ones. Anyway, so I started, of course, with very popular languages, and a couple of them were quite popular, but I mostly started with the ones that nobody ever heard of. So you can see Python is number 1. This is the FizzBuzz. Everybody knows what FizzBuzz is. Of course, that's boring. So in the same episode, I did the FizzBuzz with decorators. So basically, I'm just abusing every language as much as possible to do something stupid in it. So this is a Python decorator FizzBuzz. So every Python programmer can understand what the fuck is going on, right? That makes sense. My second language on the list was emoji code, so you can program with emoji. So I'm just trying to do different languages. Emoji code, this is the most popular emoji-based programming language. You can see that probably what it's doing by the numbers in the FizzBuzz, because FizzBuzz is not emoji. You still are trying to write in fancy letters. Of course, you can do FizzBuzz in pure CSS. And you can maybe look at all those episodes and see how the hell do I do FizzBuzz with just CSS, no JavaScript. You can make whole games this way. And I've been doing basically different things. So like there's some like embedded languages like Lua. And another interesting thing is, of course, I always write, should you use this? So I always have a recommendation if you should use a language after every episode. And this is where a lot of fanboys actually there's a lot of hating comments, because if I say anything bad about any language, and I usually say a lot of bad things about languages because most of them are bad. There's a reason we all use a couple of the thousand. A lot of fanboys come and just write hateful things on the comments, right?
Fun people, and also fun girls.
Yeah, because it's fine. So a lot of haters basically are going to say bad things about it. Anyway, so I've been going for like some old languages that people used to use in the olden days and nobody uses anymore. I do some stupid things. For example, this is a FizzBuzz, it's just regular expressions. You apply some regular expressions to a bunch of text and you have a FizzBuzz. And I also write something about how to create your own programming language. So there are some lessons how to write your own programming language. This is some Ruby stuff, that's some Python stuff, how to write programming language using Python or Ruby or whatever, one of the popular ones. I also use the funny languages. This, for example, Vonage. I don't even remember what it does. I just have to look at this. Probably FizzBuzz as well because it's the most popular case, but maybe something else. There are some Lisps, and there's some more thing how to make your own stuff. There's some practical things. There's Lorate is a tool for managing tasks. And there's some scientific languages of the 100, like Julia. This is a very nice one, actually. Nothing but to say. There's some stupid languages like XSLT. It's a completely idiotic thing. You write the code in XML, totally stupid. So of course, when I said it's stupid, all the XSLT fanboys and fangirls were just angry at me. But that's just basically how the series goes. This is even the one thing I made. This is the Z3, which we can make Sudoku solvers. That's another one fun thing. You can send this to your printer, and the printer actually runs programming language inside. People generally don't know this. So your printer can run a programming language, you send a program, and then it runs. There's some funny things like the JQ, which you can use to run some JSON, to get some JSON, process some JSON from a command line. So JQ is one of those tiny languages. There's some old ones like Fortran. You look like that's how people used to code. I have a lot of old languages. There's some pure SQL stuff. There's some WebGL, how to translate one image into another image with just pixel shaders. Some Ture, which is just substitutes one string for another string. There's some beautiful languages like Crystal. Some really fancy old languages like COBOL, everybody's favorite. Everybody heard of COBOL, almost nobody has ever wrote anything in COBOL. That is my first language I ever used, the Quick Basic. That was from when I was 10 years old. That was my first programming language, so I still remember this stuff, of course. And this is my favorite language I found during this. Is the Ascii Dots. You basically make a picture, and the dots is where the program starts. And those dots are traveling on this picture, and that's the program executing. So a dot like this travels, and it just bounces through the mirrors, follows the lines, and that's how the program is executing. This language is beautiful. Of course, it's completely practical, but I think this is a really good-looking language. And you can probably guess from this very readable what this program does by the features and the buzzers. There's like language for making music, and all the music I've made for the episode was terrible, of course, because come on. But I mean, it's an interesting language for doing stuff. And I'm 74 episodes in, and I will just end this by the last day of February if everything goes on schedule. So I definitely invite everyone to check what the languages they might be interested in. You don't have to read 100 of them. Just check which ones seem interesting, read this, and maybe you're gonna find something you like.
Which one is the most cryptic that you found?
What's the most cryptic? Like, what's most difficult to write?
Yeah, write, understand.
I think Ascii Dots probably, because you kind of want to do this. It's cryptic, but you also want to do this, because if a language is stupid like Brainfuck, you kind of like, yeah, whatever, and give up. But this is so cool, this is so fun, it's so hard, but it's so fun. It's just when you take a picture and you just try to make it run. I think this is like probably winning as the cryptic, but
Same ID for all of them, or did you use different ones?
sorry?
Did you use the same ID?
I use VS Code if possible. If not, then well, sometimes you should have no ID, but generally I try to use VS Code, so I don't, because I do one every day, so I can't just change the environment. and learn a new environment in addition to a new language. That would be like a much good option. Yes.
I'm sorry I missed the beginning of the presentation, but I found it very interesting. Did you cover assembly language?
Yes, the three assembly languages: x64 assembly, ARM assembly, and RISC-V assembly, which is this newfangled stuff that's coming. So there are three different assembly languages, and I guess VM assembly if you count this, but that's not really assembly. So this is just like a small suggestion. I mean, like you can go to the website and go through the list, or I think I started alphabetically with this list. So that is the current list. There are three assembly languages. Very basic stuff, of course. That's very, very basic stuff.
The reason I'm asking assembly because assembly stands out of all of them. Because all these languages must compile to assembly.
I mean, like there are so many layers in between often that we don't really think like that. But
I did program assembly.
yes, if somebody wants to like some introduction to assembly, I think my introduction is like quite understandable. So like a few people told me that when they had no idea what this weird thing is, for example, like Verilog, and they read the article and they actually like, oh, I got this, and understand what the hell this is and how the more or less it works. So I think this is quite good for introductory. I'm not assuming you know anything about any specific language here. Like you probably should know some programming, but like no specific language knowledge needed. Any more questions? Well, if you want to learn any of those languages or something else, just come to me during the event and I can maybe help you learn something here. Or check the website and enjoy.
So our second speaker is going to get set up now. He actually traveled by train to be here today. He came from Wales?
Yes. Hi, yeah, come all the way from Wales to talk to you guys. Brilliant. Let me set up.
Yeah, so we're very excited about this talk because it's, as I told him, because he presented the talk to me and some colleagues beforehand. We're actually colleagues, by the way. And I said, what's interesting about this talk is that's very unique because that's the thing about going to communities, to events, right? You're like, okay, I can just consume this online. I can go on YouTube and I can just learn everything. But the fact that you come here and learn from the experiences and the unique things that they have to share about how many years you said you've been working. It's like 15 years.
About 17 years in
development.
Yeah.
So there's some quite unique things he's sharing here today. So I'll leave the stage to you.
Thank you very much. Let me just get this working. Brilliant. Oh, right, excellent. Hi. So let me just introduce myself. I'm Matt Hunt. I've been, as Amanda sort of alluded to, I've been a developer for about 17 years now. Before that, I started my career as a network administrator, sort of network support, but soon got fed up of turning computers on and off, so went into development. I like lots of things: cycling, mountain biking, snowboarding, making beer, drinking the beer that I make, drinking other people's beer. Everyone's telling me to move around. Okay, good, yeah? Yeah, cool. So I just wanted to start with like a little brief history of where I've come from my career anyway. A lot of it through no real desire came from, I ended up, I should say, working with APIs. So the first one I sort of started working with was just a post endpoint, very basic, and people would just put XML to your endpoint. Usually inside there would be one field, one XML field, which would say, this is the action that I want to perform. And then you'd have to work that out, and there'd be no built-in serialization or deserialization. You'd just be taking raw XML and working out what it was that the user wanted you to do. This was horrible. So then we moved on in the world. Microsoft in 1998 invented SOAP, and this was all our dreams come true. It was going to be amazing. Food's arrived. We again pass in XML over like an RPC, so remote procedure call, call in different methods inside your system and parsing your XML. The XML that Show produced was kind of bloated and wasn't very good. A lot of people didn't like it. I certainly didn't like it, even though I had to use it. But then, along in 2000, along came REST. Uri Fielding actually created this or coined it. We'll talk about that in a second. So this was what a lot of people use today as REST. And typically, people will put JSON to a REST endpoint. Then, I think it was 2012, Facebook invented GraphQL. I really like GraphQL. As with REST, you create lots of HTTP requests back and forth, which is an overhead. GraphQL, you can actually get what you want. It publishes a schema and it almost says, this is what I've got to offer. You can interrogate that, and then you can get back all the different things in one call, which is lovely. And then in 2015, I think it was, Google invented gRPC, which I haven't personally used a lot, but I've heard good things about it. It uses the protobuf protocol. It's very slick, very quick. Very much like SOAP, it's an RPC call. So you're calling different procedures within the API itself. Rather than REST, we'll talk about REST, you're just getting resources. So what is REST? REST was introduced by a gentleman called Uri Fielding in year 2000, and it stands for Representational State Transfer. So you're transferring the state of the data that you're holding. That's the essence of it. It's only part of his dissertation, Architectural Styles and the Design of Network-Based Software Architectures. If you've got a bit of time and are curious, check out chapter 5 on REST. It is a dissertation, so it's a little bit dry, and it's a bit of a hard read. I've only read it a couple of times, but it's still up on the UCI website. So if you fancy reading up about where REST came from, this is a brilliant place to start. So what I'm here to talk to you about is a couple of points that I always consider as sort of where I start from when I'm designing or building an API. So URI and verbs, what they are, how to use them. Return data and statuses, so what comes back to the user and how we inform them of what goes on. Authentication, even if you've got a public API, sometimes some form of authentication is a good idea. Monitoring. Monitoring is just standard, I guess, in our industry today. You need to know what's going on with your system. And versioning, and then documentation. So documentation is something that is close to my heart at the moment, being in developer relations. We're all about the documentation. So that's what I'm going to talk to you about today. And hopefully I can help you learn if you don't already know. So URI and verbs. So in REST, the primary sort of data, the representative of that data is called a resource. The URI stands for Uniform Resource Identifier. So the web address that is your URI, that is essentially your ID, the identifier for a particular piece of data. The best practice for these URIs is to name your resources as a plural noun. So things like orders, customers, products, etc. And something's wrong with my clicker. If you can rename these URIs, which are like the web addresses, if you can name them well, people are going to get on with your API. They're going to be able to understand it and use it easily. So there's three types of resources that are typically used in APIs or REST APIs. The first one is collection, so an array or multiple items. Then a singleton, so your URI can address one specific resource with an ID. And then you can specify the relationship between two resources inside a URI. So let's have a look at some examples. So just as we said, plural nouns, so orders, customers, products. These are collections, and most of the time they'll return something like this. So a JSON array. This is what is typically returned. Then we have a single resource. So we can see that our resource, I missed an S off there. generally pluralized. So we'll have the identifier on the end of the URI. So this whole address is actually the identifier for that piece of information. And it will come back something along those lines. So a JSON object, single entity. There's also relations inside your URIs. So if an order could have customers, an order could have customer lines, and an order could have, well, anything else. So we tag that onto the end of our URIs to build up the association. Then onto verbs. So we need to be able to tell our API, we need to tell it that we want it to do something, or we want an action. So we use verbs. Verbs are part of the HTTP specification, and it's just a way of differentiating between calls to perhaps the same URI. So first we've got is get. So we want it to get a resource. So we'll say, give me something, whether it's a collection or a single resource. We've got post. So when you want to create a new resource, you will post your data and it will create you a new resource. Put is generally used for updates. There's sometimes, if there's no resource already there at that identifier, then it will create a new resource. There's a bit of contention about whether it should do that or not. Should it say should it return saying there's nothing there, or should it create a new resource? But those are the general guidelines. And there's also patch. Put being an update, you're generally updating the entire piece of data. But patch, if you've got a customer, for instance, and you just want to update their first name and surname, then you can use patch to do that, partial update. And then of course there's delete, if you would like to delete them. So putting it all together, we've got some bad examples of what you could do. So post into a URI called create order. So we're mixing sort of our nouns with our verbs there, so that would be bad. Again, post to get order, we want to use post. We want to use get when we want to get something. We don't want to use post. It mixes things up and makes things confusing. And then get, using a query string parameter instead of a sort of a forward slash and then the ID. That's generally not that ideal because your querying string becomes part of your actual identifier. So not ideal. And obviously having a verb inside your URI is bad. Again, post into something that looks like an ID, perhaps that could be a bit confusing because you're saying create me a new record with this ID, and that's not always ideal, and again, not pluralized. And then post into an order, this is just, you wouldn't do this is a query parameter rather than an identifier as well. And put, again, having a verb of delete in your URI can be confusing. If we look at what could be less confusing, we'd have like post to the orders. So that would create us a new resource, a new order resource. And it's very clear to the consumer of your API what that's going to mean. And then get, you want to get a collection of orders. You want to get all of the orders. So again, it's very clear, a lot more simple than the last lot. Get me order number 1, 2, 3, 4. Very intuitive. Put, again, 1, 2, 3, 4. So these are all a lot less muddled than our last example of bad URIs, bad verbs. There's also something to consider. When we want to get back multiple resources, we're doing a get, but we don't want to get too many resources. We need to think about filtering and pagination. So when we filter on something, we've seen what a resource ID looks like. But to filter something, we need to pass in some query parameters to say, this is my filter. So it's separate from our resource identifier. So we should also, something to consider, when you're returning a lot of data to your client or your consumer, you need to paginate all the time. Don't return everything. If you've got a lot of data, giving them everything back, it's going to be too much. You're going to be using resources on your system, and the consumer is going to be taking in a lot of data, burning up resources on their side. So if they don't provide paginated data, make sure you use some sensible defaults internally when you're creating the API. And sorting is important as well. When you're filtering things, sorting is good. If you create page 1 of data and it's not sorted, when you list page 2, the data is going to be different because there's no sorting in it. You're not going to know what you should return next because there's no order in what the data is. So these are just some examples of some good sort of filtering options. Again, because we're returning a collection of data, you want to be using get, and then we have orders, and then passing in sensible values to identify what you want to paginate or return or filter on. So again, we could be filtering all of the orders by customer ID 1, 2, 3. Yeah. So that's a bit about URIs and how best to sort of use them when you're creating your own API. So when you return data to a customer or to a client, you want to be able to tell them what's happened. They're going to request something from you or give you an action. You're going to need to say, right, has it succeeded? Is it in the middle of working? Or has it failed? So HTTP, we've got status codes. So status codes inform the client if their request has been successful, if it's failed, or another status. There's over 70 status codes listed officially for HTTP, so it's best to sort of stick to just a few. One customer I worked with years and years ago, they decided that they only wanted to stick with a few, but they weren't going to use the official ones. So they took all of the ones they wanted to use, gave them new numbers, and then everyone in the company then had to work out this whole thing. And it just got very confusing and didn't really work. So sticking with the official ones is the way to go, and just using a subset. I've got a list of sort of just the common ones. These are pretty much all the ones that I stick with, unless I'm going to do something different. And then I will look for a specific one that suits the situation. Potentially like 480 or 420. They're all very unique and specific. But you will see, so 200, this generally returns, if everything's worked and it's all good, you return 200, it's okay. Created, so if we do a post or a put, and you've actually created a new resource, you're going to return 201 and say, yeah, it's all created. I'm not going to give you anything back, but it's all good. 202 is an interesting one. I'm not going to go into depth on too much, but if you want to create something, but you're going to do it asynchronously, so you're going to say, right, I haven't done it right now. I'm going to go away and work on that, but trust me, I'm going to get it done. So you'd return 202 and say, yeah, we're working on it, and then perhaps you have another mechanism like a webhook to feed them back to say, I was working on it, now I'm done. So return that back to the customer. Everyone's seen 404, again, not found, and bad request. So bad request is often used for validation. If someone gives you some data, so they want to create a resource, and there's something wrong with that data, be it structurally or from a sort of a domain side of things, it doesn't quite conform with your business rules, then 400 is the way to go. So Hatius, if you read any sort of articles on like the design principles for APIs, they often talk about Hatius. I'm not sure if I'm pronouncing that right, but it stands for hypertext as the engine of application state, a bit of a mouthful. What this actually means, so all of the guides on how to create APIs say you should do this. I personally, in the sort of 15, 17 years I've been doing it, I've never really consumed many APIs that have implemented it or done it myself. But what it says, and it's part of REST itself, is it says it should be possible to navigate your whole system or your resources without prior knowledge of the data that your API owns. So each response that you give to your consumer should actually contain some links or some data to allow them to navigate the rest of your system, whether it's creating a new resource or going to the next page of a result. given a link, a URI, is what is recommended. As I say, I've never really needed to do this, but it is part of REST, and a lot of people do say that it's needed. But it's one of those things that can be used or not used. It's up to you. This, I tried to give an example of this, but it turns out JSON as an example gets really hectic on slides. So, but this is an order ID, and it's got some, this is your order data, and then it's got links to other functions. So you could get the customer of the order, it tells you the URI of the customer, and if you wanted to delete the order, it gives you the URI to delete it and the action to take. So this is an example of Pages. It's a good, it is a good idea. I just don't think that, me personally, I don't think that a lot of APIs are in that sort of maturity. But if it works for you, then use it. So another good idea, and this is something that I've done sometimes and not done sometimes, is a standardized sort of response body. So if you're getting an order, you're just going to get the order data. If you get the customer, you're going to get the customer data. But what if you could get the customer data and other information that might be needed? So a standardized response body is a good way to do that, to inform the consumer of something else, not just the information that they wanted. There's no real sort of standards for REST in JSON response bodies, so you're kind of just winging it. A standard response body will definitely aid whoever's using your API. It's going to help them know what they're going to get back. So they can say, right, I know I'm going to get these fields, but I'm also going to get this bit of data that I requested. So here's an example of what I'm sort of talking about. This is taken from Google's JSON style guide, which is actually quite good. So we're getting, this is the item that we wanted, the sort of the ID and the name, but we're wrapping it in a data object. Once you've got that data object, we know that that's going to be our data inside that. But then also, at the same level as the data, we can add other things. We could add our HS links. We could add any sort of information about pagination or sorting. The list is endless. Here's a collection. So as I mentioned, we've got our data object. We're passing back the items, but we're also adding other information so that the consumer will know sort of how many items we've got, the page index if it's paginated, how many items we're actually meant to be given back. This is quite, the times that I have used a standardized object for all of my requests, it helps a lot. It helps you as a builder of the API, because there's a standard way of doing things, and it also helps the person that's consuming the API, because they're going to be like, well, I know I'm going to get this sort of thing back. It's also a good idea to have a standard response error message. So we're going to be using our status codes to say, right, it's either good, so anything in the 200 sort of range, okay, or created, or we're going to be giving them back sort of an error status to say, like, something's gone wrong, 400 or 500. So if you detect that something's gone wrong, then we can give them back this error object, and they know that that's the sort of data they're going to get back. And then they can deal with that appropriately. So that's the responses. So another important part of any sort of API is authentication. There's a couple of types of the auth that sort of stand out in sort of the common world. API key, basic authentication, and OAuth 2, which is pretty ubiquitous at the moment. I nearly said ubiquitous everywhere, obviously. Right, so the first one, API key. So using API keys is a good way of authenticating one system when it talks to another system. You don't generally get information about a specific user. It's just, I've got a program here that wants to talk to your API, so this is the access that I'm going to give. Generally, APIs keys sort of come either passed in as a parameter, so you're saying the key is this, or in a header value. So I know that Google actually does a lot of the API keys in the query strings from the APIs I've used, and then an auth key. If you've ever worked much with header values, a lot of people use X header values as a custom thing. That is actually deprecated. It's been deprecated for a long time. I only found this out the other day. So I've been using X headers as like my custom headers for a long time. Turns out they've been deprecated for years. But there we go. So that's API keys. You could give this out to a client or a customer. It could be their secret. As with everything, there's some good points. It's relatively simple to understand and implement. Bad points, it only identifies the application that's calling your API. So if you need to know who the specific person is that's calling it, you can't do that. It's just the system. They're difficult to keep secret, especially if you put them in JavaScript or something like that. Then the world's going to know what your secrets are. Also, if by accident you decide that you're not going to use SSL and you're just going to then everyone again is going to know your secret. And they're not standard. You saw my use of an X header value. That's custom. There's no standards really for API keys. Right, the next one, basic authentication. We've hit a standard, amazing. So this is part of the HTTP standard. It's been around for years. It's a simple method to pass a username and a password to the calling system. So it does identify a user rather than just an application. And it is created with, you create a string with your username, your password, separated by a colon, and you base64 encode it. You then pass it in a standardized header, the authorization header, with the schema of basic. And then there's your token on the end. So good points and bad points of this one. It's a standardized way to create credentials. It's very easy to learn and understand once you know that you've got to join the username, password, and base64 encode it. It's fairly simple. One bad point, or first bad point, is that the application gets to see the user details. So the person that codes the API, if it's yourself or someone else, you'll be able to see the username and password of the person that it's connecting to. So it only takes one bad actor in your organizational company, and you've lost all your passwords. They're exposed. Good formatting. Another downside is the passwords are long-lived. Unless you go and change your password quite often, then if you do get them exposed, then there's no real easy way of sort of terminating that. And multi-factor authentication is not really possible with this situation. You're literally just passing your details to the calling system, your API. And then we go on to the last one, which is token-based authentication with OAuth 2. So this relies on the fact that you pass in a token to your system, and it's a trust between the token provider and your API. I'm not going to go too into depth on this. There's a million resources out there, and I'm not an expert on OAuth or security in any shape or form. But I do know that once you do get your token, you pass it into your authorization header using the bearer schema. So this is the schema that identifies what sort of authentication you're doing. Well, I am not an expert, but I did do a pretty diagram. So this is roughly how it works. Can you see this? Sorry, I should have done it bigger. So as a user, you try and access your application. The application will then say, no, you need some authentication. So it will redirect you to your third-party authentication service. So you then pass your authentication, your details, your username and password, to the authentication service, which then passes your credentials to the app. Your app then talks to your API, and your API goes, yeah, I know that token. I trust that authentication service. Here's your data, and it returns the data. So looking at the purple arrows, those are the only places where this security information is passed. So the first one is just the username and password. So none of your system is exposed to that, so there's little chance of it being compromised. Good points and bad points. Standardized way to send credentials. It's Yeah, pretty standardized. Tokens have a time to live. So your tokens are only short-lived, like let's say 15 minutes. So if you need to cut someone off, if they haven't paid the bill or if they're doing something wrong, it's quite easy to say, no, we're not going to give you another token. That's it. You're done with us. Pay your bill. And the application, so that your API will never see that username and password. So again, it takes out that whole bad actor, that person that wants to take down your company, can't do it anymore. Not in that way, anyway. Good formatting again. And multi-factor authentication is possible. I bet everyone's got the Google Authentication app on their phone. Yeah, so you can do that and make people's lives just that little bit more tedious, but secure. So, good point. It's ubiquitous. It is everywhere, as I've said. Everyone's used Facebook, so they must have used OAuth too. Some downsides, it can be hard to implement. I've been doing this a long time, and I still am not anywhere near sort of competent. So I let other people do that, and it's not 100% without risk. Nothing is like there's been instances over the last sort of 10 years where even this has been sort of compromised. So it's pick your poison, whatever suits you. There's 3 different authentications there, and it's a juggling act to what works for you and what you need. On the first one, so like the key, so API key authentication, that's good if you've got a public system that you're just giving away for free, because you're still putting some layer of security in there, but you can still track the users that are using your system. Which brings me on nicely to the next point. So monitoring. When you're building any system, whether it be an API or anything, monitoring is important. So without knowing what your API is doing, you don't know if it's been broken into, if it's down, if it's up, if it's crashed. You don't know who's using it. You don't know who's abusing it. So you need to monitor things. Excuse my my badly formatted slides. So a few good things to monitor. Availability. Is your API up? Is it working? Can you get a response from it? Or is it returning an error? That's always sort of a standard one. Responsiveness. How quickly is it giving you data? If you're returning data in like a millisecond, like you've won. If you're returning data in 30 seconds, something's wrong. Something's wrong with your system. It's either that you've written some bad code or you've deployed something badly and you need to take it out or tweak it. Requests per minute, that's a good measure of is it working okay. Data validation. And this is one that might not come out as sort of an obvious point. It's really good to, when you're creating an API, is to log every request you get and every response you give, because and log that against the user that's doing it. Because sometimes if you can monitor, say, like a user, and you can see their requests coming in, and you can see that they're hitting the data validation error all the time, then perhaps that's a way that you can then reach out to that customer and say, are you having a problem? And that's going to give you kudos points, because they haven't phoned you for a problem, but they're getting a problem. And now all of a sudden they get a phone call saying, no, you've got a problem. And they're going to think, oh, this is a great API. These people have just contacted me because they know I have a problem. Right format. So unhandle exceptions. So you're always going to find some exceptions in your system. A lot of them are going to be caught. You're going to sort of catch them and act appropriately. But every now and again, unhandle things you weren't expecting are going to happen. And if you can monitor them and see that the rate of exceptions shooting up, you know that you've done something wrong or that someone is doing something wrong. So capture them. And that's it for monitoring, really. It's another big subject, but just knowing that if you're going to build an API that's going to be used, monitoring is something that you should really think about near the beginning, before it all goes to hell, really. So versioning. This is actually something that I think is really important when you're building an API. I built an API about 7 years ago now for a company and returned a few times over the years as a contractor. And when we built the API, it was version 1, and this is 2015. And I've gone back now, and it's still on version 1. But we had it in there from the start. So we always knew that we could change the version if we wanted to. So let's talk about that. What is API versioning? So versioning is the practice of transparently managing your changes to your API. So over time, things will change. You learn how to do things better, or your needs become different, your customers' needs are different, or you realize that you've actually designed your API completely wrong, and you haven't listened to any of my slides, and you now need to do it all over again. So that is when you'd make a new version of your API. One thing in here that is kind of important is transparently doing it. So doing it so that your consumers know that it's a new version, so they're not suddenly on a new version, consuming this whole different API that you've made, and everything their end is broken. So when to create a new version of an API? So if we talked about URIs early on, that's the identifier for your information. So if you change how those identifiers work, the structure of them, then create a new version. Breaking contract change. So the structure of your data that you're returning is essentially a contract with the consumers of your API. It's saying we promise to give you this data in this format. So if you're going to change it in some way, like what you return, what you require them to send to you, or change the type of data, so from an integer to a float, or from a string to a Boolean, which is something that I'm going to be doing soon for our Vonage API, for one of our SDKs, anyway. And taking away something, so removal of part of your API. If you've had a service that, like your bike rental service, it flopped and you're not going to use it anymore. So you want to just deprecate it, you're going to take it away. So perhaps create a new version of your API so that there's knowledge for the consumers that it is going to disappear, it is broken. So you should always, when you're thinking about this, maintain backwards compatibility. So keeping an old version running for a certain amount of time, it's going to allow customers or clients to be able to update to the new version. So you've still got that old version there for a certain amount of time. This is something that Google is really good at. It's thoughtfully sunset or obsolete like your endpoints or properties. Maybe about 5 years ago, I worked for an insurance comparison site, and we quite often got emails about Google versions or APIs of Google's that are changing version, and they were like, "We've got 1 week left before the new version goes out, and your old version is dying." And we're like, "Oh my god, where did this come from?" And it turns out that people just forgot to read the emails, so we had to do a lot of changing of these things. But yeah, thoughtfully, they did send us emails, which is brilliant. So if you're going to do a new version or take away a version, communicate with the people that use it. This is something that I've always thought was good and I've stuck with. It's a maximum of 3 versions. You can't keep an old API, an old version of API running forever. It's a waste of money and it's a waste of time, and eventually the usage will be so little that it's just not feasible. Again, I contracted a lot, and there was a company that would just keep all of their versions running forever. And I was like, no, you need to turn some off. They're like, yeah, but people are using them. I'm like, yeah, but you've had the new versions for years. Just ask them, please, can you update, and we can turn this old system off. So 3 versions is my sort of max, really. So you've got your old version, your current version, and your new version. And that just keeps moving as the sort of versions move. So yeah, 3 versions. So backwards compatibility. So I've got 3 rules for backwards compatibility. Rule 1, don't talk about backwards. No, that's a different film. Don't take anything away. Rule 2, don't change the meaning of anything. So if it's a string, leave it as a string. If it's a Boolean, leave it as a Boolean. If you change it, new version. And all additions are optional. So if you're saying, for this request, if you want to create an order, then you need to give us this bits of information. If you suddenly think, right, I need to add a new field, that's fine. Adding a new field is perfectly fine without having to create a new version. But don't make it the required field. Make it optional. Make it so that they can fill it out if they want, or create a new version. So there's 4 types of versioning. URL versioning. So here's a common one. Just put in v1 on the end. Another one is using like a host name. So API v1.example.com. And you don't have to use like v1. You could just have 1, or you could have the date, or anything you choose, as long as it's meaningful to you and perhaps your clients. You could have your pet's name. You could have Star Wars characters, as long as there's some sort of identifier to say this is a new version. So another one, query string parameters for a version. This is kind of cool, but it's kind of not cool, because if you then using sort of products, that becomes your URI. So that's now your identifier. And as we talked about earlier, we try not to put identifiers in query string parameters. So we don't really want to put a version like that. But again, it's there. It's a way to do it. Another one, which is the API that we built that's on version 1. We used custom request headers. We used this custom request header. And as we now found out, X is deprecated. But yeah, very, very valid ways of doing it. And then content negotiation. Now, this is a version of API versioning I haven't used myself, but it's something that I'd like to explore, and hopefully you'll get to. But it's another way, using the sort of content negotiation system. This can be, from what I've read about this can be quite hard to test. Some of the other ones are a bit easier, but if you're doing automated testing, then you're going to be hitting the same URLs, URIs, but with different information and requiring different returns. So that's versioning. It's important. Even if you never think you're going to go to version 2, try some sort of versioning. And the last one, this is really important in my opinion, documentation. I know it's the enemy of every developer. I hate documentation. And now I'm in DevRel, I've got to write documentation all the time. That's my job. But documentation is a key part of making something, and APIs especially, because there's no handbook given out when you've got an API unless you've done the documentation, which is your handbook. So why should we write documentation? Well, it improves the experience and the lives of developers using your API. If you don't know how to use something, then what's the point? You don't get a Lego set without the instructions, because that would be rubbish. And it's very much for APIs. So we're going to also decrease the amount of time for new users of your system. Again, they're kind of linked. You want someone to consume your API, to be able to know how to use it. Getting up and running is just quick. It's really important. And it cuts down on the frustration and the anger that people may get if they can't use your system. So again, if you're running a commercial API, it saves support time. The more documentation you can create, then the less problems people are going to have, the less time and money you have to spend trying to help them. And you can put the money to use creating a better API. And you can identify bugs or inconsistency in your architecture. This is quite an unusual one. But writing down how it all works and how to use it, you will find things that you think, all right, I've done it different in this one area to another area. So you can actually identify things where you've been inconsistent. How do we documentation? So a lot of people may have heard of Swagger, if you've been around as long as I have. This is sort of uses an open API specification. This is a great little tool. I'm not going to read this out. This is what they say their tool is, or their specification. It just helps you learn what an API is capable, its capabilities, its endpoints, what you can do with it, without sort of writing much documentation. This is sort of self-documenting. The code will document this for you. if you're interested, go to swagger.io, and there's lots there. I just thought I'd give you, this is what sort of the Swagger interface that uses the OpenA standards looks like. So you can see, it tells you, this is one of our APIs. It tells you what functionalities it's got and enables you to interrogate these endpoints. And it's a great one. It's a great one not only for the consumers of your API, but someone that's actually creating it. If you're creating your API, you can actually use it through this documentation endpoint. Yeah. Yeah, that's terrible. Good point. Yeah, this is. So yeah, sure. So it's just been pointed out that we have a post endpoint with creating, which goes against everything that I just said. So yeah, that's and singular. So yeah, perhaps don't copy this one. This is actually so. That's actually a good point. Documentation as well. If you create a bad API, then quite often your documentation is going to be bad because you're basing it off something that's wrong in the first place. And also, if you're creating SDKs, which is my day in, day out job, creating an SDK for these endpoints, then that could potentially be hard to use because you're basing it on an API that's hard to use. So this is why APIs it's good to get it right. So this is taken from a lot of my experience now as a developer relations person. Having a developer website is actually brilliant for people consuming your API. So you can have get started examples, tutorials, sort of forums and communities, use case examples, and solution examples. So like a healthcare solution example, an education example, having those sorts of things brings people towards your API. And reference documentation. So a list very much like your Swagger endpoints, but more in a human readable format. Yep. Oh, a few of these.
Someone in the comments said it's weird.
Okay, sorry. Right. And yeah, a shameless plug. If you want to look at developer.vonage.com, that's how we document everything. And also blogs are really good if you're creating an API, blogging about it, because you can do sort of full demos of use cases, which you perhaps wouldn't have in the documentation. You can have unique uses of the API. So as a developer relations advocate, we try and think of new ways to use our systems to put into blog posts so that people can think, oh, I'd never thought of that. And then it's a chance, blogs are obviously a chance to connect to your customers or your consumers. So that was it. I realized it was quite theory heavy, and I hope you've gleaned something from it. The 6 key points are sort of the takeaways. If there's anything to take away, it's just those 6 key points from it. And yeah, any questions? No?
About the documentation, right? So documentation is really important.
Yeah.
Documentation, unfortunately, tends to become obsolete quite often. So, what's the best strategy trying to keep up?
Yeah. So for the online people, the question was documentation can often become stale. So, what is the best way to keep that aligned? So, for me, I think if you're going to create new things, that's what the point at which your documentation becomes stale. So you either a strategy you can take was every time there's a new thing, update the documentation. There's also auto-generated documentation, and that can only go so far in helping present it in a user sort of friendly way. So you could also in your build pipelines, perhaps if you're lucky enough to have build pipelines, create the documentation there and publish it straight away. So every new change goes straight out. But as an easy step is if there's a new version or a new edition, do the documentation as part of that work piece. Yeah. Well, yeah. So the question was, JSON is pretty verbose. Is there any recommendations to make it simpler? Use gRPC. So it is what it is. How can you get the right information across to the user in the smallest way? I think that's it. It depends. Like JSON is designed as sort of human readable, really. So any smaller, then perhaps you're losing that human readable part of the JSON. Obviously, you can take out all the white space and sort of minify it, but it's I guess it's a balancing act between giving the consumer the information they want and creating that small packet size almost. As I said, there's different protocols out there that aren't REST that will send that information in smaller size, but then what you gain in sort of speed, you perhaps lose in other areas like human readability.
There's a question from remote.
Yeah.
From Jawad Alam. He said, putting key info in the headers, is it safe?
Key information?
Yeah. Putting key info in the headers, is it safe?
Oh, key. So like API key. Yeah, it says key. So API key, if you put that in header, if it's across, this is something that I forgot to mention actually. If it's across HTTPS, then yeah, all your header information is encrypted. So carry on. There's just trying to think of anything else that would affect it. As long as you're sending everything across HTTPS, if you're going to create an API that's going to be consumed in the real world, don't use just straight HTTP. Always use SSL or TLS, just for the sake of safety's sake. Always err on the safe side of things. And yeah, all header values are encrypted with HTTPS. Anything else? Any other questions?
Someone said that they want to steal that painting from David Girl. That's amazing.
Okay.
No more questions.
So if you send me your details, I'll steal it for you, and I'll NFT it too. Anything else? Well, thank you very much. Oh, one more question.
From the moment that you are getting the confirmation from the authorization.
So how does having a token make it more secure? Okay, so the question was, how does using a token for authentication make things more secure? So there's a couple of things. As I said, I'm no security expert. So the token is short-lived. If you steal a token, then it's you've got a time frame to use it. So in theory, you can, if you manage to get someone's token, you can use it in that time frame and go crazy. So in that way, it's not secure. But the fact is that if someone finds out the token, you can cut them off. You can cut them off at the end of that point. You're not, the only time that the token is sort of shared is between the third-party service and your app and your API. So there's that whole flow should be done again over HTTPS, which is as secure as it is. It's as secure as we've got on the internet on a day-to-day basis. So the fact that it's always sent across those channels is the security itself, as far as I know. Okay, any more questions? I'm around all evening, so feel free to contact me. My details are around. Vonage have a public chat community. If you do want to ask me any questions or questions about Vonage, feel free.
Thank you.
No problem.
So to the people who is watching online, that was it. Those were the 3 talks. Thank you very much. We're going to stop now because we have a lot of pizza and things to eat around here. So thank you for watching from all these different countries that you joined. We'll see you next time.